Welcome to this video on literal equations. First thing I'd like you to do is to pause the video, but I want you to try and solve these two equations right here for x. Solve each equation below for x. Then restart the video and we'll begin the notes. All right, well, let's take a look and see how you did. So on the left, this was a regular two-step equation that you're pretty familiar with how to solve. You should have gotten x equals 9. First, we added 5 to both sides. Then we divided by 2 to both sides to get the x alone, and we came up with x equals 9. Now, this problem on the right is also a two-step equation. You would have followed the exact same process as you did on this one for this one. But the difference is this equation is made up of letters instead of numbers. So in the left-hand equation, we added 5 to get started. Well, we're trying to get to the x, so we added b to get started this time. That left just the ax on the left, but c and b are not like terms, so we're just going to write them c plus b. Then we had to divide off the a in front of the x, so we divide both sides by a. The a's cancel on the left, leaving just the x, but on the right, I have c plus b divided by a. So there are some similarities and some differences. The similarity is both equations used inverse operations. So we use inverse operations to isolate the variable. Okay, but they were different also. Here in our numerical equation, when we use the inverse operation, the 5 disappeared from the left and combined with the 13 on the right. The 2 disappeared on the left when we divided by 2 and it reduced the 18 on the right. But in this equation, none of the letters went away. We weren't able to simplify nicely. Okay, so the literal equation, and we'll talk about that in just a second. This one is a literal equation. Has a lot of different letters. And those letters won't simplify nicely. The many letters, we're going to call that multiple variables. So it just didn't simplify down pretty. But that's the very definition of a literal equation. We look here. A literal equation is an equation that contains more than one variable. So our equation up here on the left only had an x. So it's not a literal equation, it only one variable. Our equation on the right had 1, 2, 3, 4 variables in it. And so it's a literal equation. So what we're going to be doing is we're going to be solving literal equations for a specified variable. So we're going to start with some one-step problems. So here's the equation, A equals LW, area equals length times width. And we want to solve for W. So that means I want to get W by itself. Okay, so let's zoom in a little bit here. To get W by itself, we have to look, it has this L attached to it. Well, L is multiplying to W. So to undo the multiplication, we're going to divide both sides by L. Remember that division property of equality. If you do it to one side, you got to do it to the other so they'll remain equal. So the L on the right cancels out, leaving just the W. On the left, A cannot be divided by L. They're not like terms. So we're just going to write A divided by L. And that's your answer. This comes up a lot, especially in, say, science, where they have you rearrange a formula for the one variable you don't know. And so you'll see this again more than likely in your science class. Let's try it again with number 2. A equals BH. Area equals base times height. Okay? So we want to get the H alone. So here's the H. That's what we're trying to get alone. The B is multiplying to the H. So to undo the multiplication, we're going to divide. That's that inverse operation. And if you divide one by one side, you have to divide the other, so they'll remain equal. The B cancels here, leaving the H. A cannot be divided by B. They're not like terms, so we're just going to write A divided by B. We rearranged our literal equations. Okay, then we have distance equals rate times time. I want you to pause the video, try it, and see how you do. Okay, let's see how you did when you solved yours. It says solve for T. So here's T, and it's multiplying to the R. So we have to undo that multiplication through division. And our property says if you divide one side, you got to divide the other. So the R's cancel, so I have T, and D cannot be divided by R. So we're just going to write it like that. This is what happens with literal equations. Things do not disappear because they're not going to cancel out. They're just rearranged is really what's happening. All right, one last one. So these were all one step. We only had to do one thing to get a variable by itself. It's a fraction, and I know you guys don't like fractions, but they do happen, and we have to deal with them. So we have D equals M divided by V, and we want to get M by itself. So here's M. M is being divided by V. So how do I undo that division? I undo the division through multiplication, the inverse operation. Okay, so if I multiply by V, that's going to cancel like that. But our multiplication property of equality says we have to multiply both sides by the same thing. So D times V equals M. And that's it. That's all you got to do. So those are one-steppers. They do get more complicated. Let's try some on the back. Okay, so on the back, I gave you some hints. It's just like solving a multi-step regular equation. The rules are not any different. How it looks a little bit different just because of all the variables. Okay, so I want you to keep in mind PEMDAS backwards. When you're solving equations, you're going to add or subtract first, then multiply or divide. That's what PEMDAS backwards means. So really, we're reading it in that direction. To remove fractions, you're going to multiply it by the reciprocal. And the last step is usually to divide by whatever is next to the variable of interest, okay? So let's try one here. So we have A equals 1/2 BH. Area equals 1/2 base times height. So that's the area of a triangle. And we want to get H alone. So here's H. We want to get him all by himself. Everybody else on that same side needs to move. All right, so what are we going to do? We have 1/2 times base times height. So if I look, it says add or subtract first. Well, there's no add or subtract. Then multiply or divide. We remove fractions by multiplying by the reciprocal. Let's get rid of the fraction. We can remove it by multiplying by the reciprocal. The reciprocal of 1/2 is 2/1. So if I multiply this side by 2/1, the 2's cancel and the 1's cancel. But I need to now multiply this side by 2/1 also. And in reality, your A is also over 1 to kind of help you visualize what's happening here. Okay, now let's do a little simplifying. So I have 2 times a, which is 2a. We're not going to write the ones, it's just kind of a placeholder to help you see it. The 1/2 canceled out, and what I'm left with is b times h. Now this is very similar to what we were just doing. I'm trying to get the h alone. The b is multiplying to it, so I'm going to have to divide off the b, which means I need to divide on the other side too, the equals. These b's cancel, and here we have 2a divided by b equals h. And that's our final answer. Okay? Well, let's try it again. This next one, it's like the same exact problem with different letters. Okay? Just like solving an equation. It's the same steps, just with different numbers. Okay, so we're going to look for addition or subtraction first. We don't have any off of here. We want to get b alone. So we want this big B by itself. So this is a volume of something. I'm not sure what it's a volume for, but it's a volume. Let's get rid of that fraction. How do you get rid of a fraction? You multiply by its reciprocal. So instead of 1 over 3, I'm going to multiply by 3 over 1. And the fractions cancel. Boom, gone. But remember, you have to do it to the other side also. So I got 3 times v, which is 3b, equals big B times h. And I want to solve for the big B. Big B is multiplying to h, so to undo that, the inverse operation is divide. Divide by h, divide by h. Those h's cancel, leaving just the b. So your answer, 3v divided by h equals b. All right, how you doing so far? Hope you're doing good. Okay, let's take a look at number 7. Number 7 is also a fraction, but it is different. Notice it's got some addition going on. And I did say up here, add or subtract first. But really, it's between terms. I only have one term on this side because there's no adding or subtracting outside of that term for there to be 2 terms. Okay, so that means we need to get rid of the denominator first. The denominator is d. I'm trying to get b by itself. There's b. That's who we want all alone. So let's get rid of the d first by multiplying by d. Remember, if you multiply one side, you have to multiply the other. A times d is AD equals, and those d's canceled, b plus c. Now I have 2 terms over here. Now I can deal with the addition or subtraction. I'm trying to get b alone. The only other thing on that side right now that has to be dealt with is the plus c. So we're going to subtract c from both sides. Now we had a times d. He doesn't change. Well, you cannot subtract c from a times d. So we're just going to write minus c equals, those c's cancel, and there's your b. Okay, let's see how we're doing. So this guy, what are you trying to get alone? You're trying to get y. Here's what we want. So I have 2 terms. You have to add or subtract if there's 2 terms going on. So this is the term that's staying here for right now. So I want to get rid of the ax. It's a positive ax because there's no sign in front of it, so I'm going to subtract ax from both sides of the equals. Okay? This ax cancels, and I'm left with by equals c minus ax. So now I have b times y, and I want y alone, so I have to, the inverse operation is divide by b. This whole side is going to be divided by b. But there's not going to be any simplifying, so we can actually, I'll show you how we can simplify it. So this cancels. We have y equals c over b minus ax over b. Because they're both over b, c minus ax over B. It's kind of junky, and I know we don't like fractions, but we do have to deal with them. All right, 2 more. So here we have a perimeter. Perimeter equals 2 lengths plus 2 widths. We're going to solve for W. So we're trying to get this guy alone. There's 2 terms on this side, which means I need to get rid of the term that doesn't contain the variable that I want. So I got to get rid of the 2L. It's a positive 2L, so minus 2L, minus 2L. So I have P minus 2L. They're not like terms. I'm just going to write P minus 2L equals, that cancels, and I'm left with just 2W. Okay, I want the W alone, and the 2 is multiplying to it, so the inverse operation of multiplication is division. Divide each thing by 2. Okay, P divided by 2, they're not like terms. P divided by 2. Negative 2L divided by 2. Oh, look, those 2's right there would cancel down to a 1. And it'd technically be over 1, but we're going to just leave it like that. And then equals, those 2 cancel and leaves just a W. P over 2 minus IL equals W. Now, one last one. There's a couple ways to handle this guy. Your first thought, I already know, is there's a parenthesis, I should distribute. Well, we can do that. If that's the way you want to handle it, we can do it. So y equals, and if we distribute this in, a times n is going to be an. 1 times n is going to be 1n. Okay, so I want to solve for a. Here's a right there. See how I have 2 terms? I got to move one of them over. So I'm going to subtract n, 1n from both sides. And I have y minus 1n equals an, because this one canceled. Now we want to get a alone. A is being multiplied by the n, so inverse operation says divide by n, divide by n, divide by n. And you have y divided by n minus, these n's cancel, leaving just the 1, equals a, because these n's canceled. Y divided by n minus 1 equals a. All right, I'll see you in class.